Hello everyone, welcome to Rasaayana Institute of Sciences. So in this video we are going to discuss aromaticity question series, how aromaticity questions are asked in variable entrances, especially IIT as well as Neet examination, and this particular video is going to be a rank deciding video, especially for the concept of aromaticity. Okay, now see, if you see this question clearly, the number of aromatic compounds among the following are, I given a group of molecules. In that group of molecule you need to choose which is aromatic among the following set of molecules. So later on some more additional questions are given, but right now I given a group of molecules, just select which is aromatic and based on your analysis. Okay, so is it aromatic? No, it is not an aromatic molecule. This molecule is completely, be careful, it is a non-aromatic molecule because it is a non-planar, non-aromatic. And here remember, it is looks like a naphthalene, but it is not naphthalene. Even 10 pi electrons are present. This molecule is completely non-planar, non-aromatic. This is called 10-annuline. And this is called imidazole. In imidazole, 6 pi electrons are delocalizing. Here 2 pi electron, 2 pi electron and 2 non-bonding electron. These 2 non-bonding electrons not involving in delocalization. So this imidazole is found to be aromatic in nature. So A is nothing but aromatic. Now this is a 4 pi electron delocalized skeleton, 1, 2, 3, 4, only 4 pi electrons are delocalizing, this is anti-aromatic. Now here, out of 2 lone pairs, inner lone pair involved in delocalization, 1, 2, 3, 4, 5, 6, 6 electrons are delocalizing, this molecule is said to be aromatic. Okay, now open chain doesn't show any kind of aromaticity, it is not shows any relation of aromatic, anti-aromatic, anything. So don't write this one because non-aromaticity, aromaticity, anti-aromaticity applicable only for rings. So don't apply this one. And this molecule carry 1, 2, 3, 4. Total 4 electrons are there. It is belongs to anti-aromatic. Now here, one lone pair is present. That lone pair, here positive charge I written. Now 1, 2, 3, 4, 5, 6. Total 6 electrons are present. 6 electrons are delocalizing. Now it becomes a aromatic. And here also see 2 lone pairs are available, but they are not involving in delocalization. Total 6 electrons, that is 6 pi electrons are delocalizing, it is aromatic. Now see, this skeleton carry sp3 carbon. Due to presence of sp3 carbon, there is no proper delocalization of electron. This sp3 carbon deviates the delocalization of this set of electron and this set of electron. So I can say this molecule is belongs to non-aromatic due to presence of sp3 carbon. Now, if I migrate this pi electron here, you will get positive charge. It is looks like a tropylium. It is aromatic. 6 pi electron delocalization. And here there is a presence of empty p orbital on boron. Boron carry empty p orbital 1, 2, 3, 4, 5, 6. 6 pi electrons are delocalizing and this is aromatic. And if you consider this one, every lone pair on a carbon becomes 2 electron skeleton. Okay. So here 1, 2, 3, 4, 5, 6. Now it is 6 pi electron delocalization and this is aromatic in nature. You can write even negative charge over here. Okay. Next, if you consider this particular element, this is called benzene. 1, 2, 3, 4, 5, 6, 7, 8. Generally benzene, 8 pi electrons are available, but remaining 2 pi electrons, especially these 2 pi electrons, they are completely away from delocalization of this set of pi electrons. So inside of the nucleus, only 6 pi electrons are delocalizing. It is found to be aromatic in nature. Remember, this is called benzene, not benzene. Benzene is aromatic in nature. Okay. Later on see, this skeleton having 1, 2, 3, 4, 5, 6. Total 6 pi electrons are delocalizing. 2 radicals are quite opposite in direction. It is not involving in delocalization, these 2. So these 2 are not involved in delocalization. Only 6 pi electrons are delocalizing. I can say it is aromatic. And finally see, this skeleton having sp3 carbon, but this is one exception case. So here 6 pi electrons are delocalizing. 1, 2, 3, 4, 5, 6. So by crossing this sp3 carbon, 6 electrons are delocalizes. 6 pi electron delocalizing. This is mostly belongs to homoaromatic. Every homoaromatic molecule is belongs to aromatic in nature. Every homoaromatic is a aromatic molecule. So I can say aromatic, 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 and this is also aromatic, and this is also aromatic, and this is aromatic, aromatic. So wherever I written A, that all are belongs to aromatic molecules. Just count the total number of aromatic molecules and your answer will be written over here. The number will be written over here. Okay, next. Next question. See, aromatic among the following. And if you see this molecule clearly, there is a presence of carbonyl group which is conjugate to double bonds. Now these pi electrons are simply migrating on this one. If they migrate, here you will get pi positive. So after getting positive charge, 1, 2, 3, 4, 5, 6. 6 pi electrons are delocalizing. It is aromatic in nature. And if I take this cyclic amide, this lone pair of electron and this lone pair of electron also involved in delocalization. And if I consider by transferring this pi electron and by transferring this pi electron, total number of pi electrons are 1, 2, 3, 4, 5, 6. Here you will get positive, here you will get positive. Finally, 6 pi electrons, it is also aromatic in nature. And this is called imidazole. A lone pair of electron, here also one lone pair is present. This lone pair involved in delocalization. Here 2 pi electron and here also 2 pi electron. This is not involved in delocalization. So total 6 pi electrons are delocalization. So your answer is all. So all are aromatic in nature. Okay, next question. Which of the following species are aromatic in nature? So if you see first molecule, total number of pi electrons are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this molecule carry 14 pi electrons are delocalizing. 6 pi electron delocalization, 10 pi electron delocalization and 14 pi electron delocalization is aromatic. So I can say it is aromatic in nature. Okay. Now see, this is non-planar, it is not aromatic. Already this point explained just now. And this molecule carry 8 pi electrons, oxypine. 8 pi electrons are present. 1, 2, 3, 4, 5, 6, 7, 8. 8 pi electrons are present. So this molecule is also not aromatic. It is anti-aromatic molecule. And see, due to presence of sp3 carbon, this molecule is non-aromatic. So your answer is A. Next. The species aromatic in nature are. So which among the following is aromatic in nature? Fourth question. C. This is called cyclopropenyl cation. 2 pi electrons are delocalizing. All are sp2. So I can say it is belongs to aromatic due to 4n plus 2 pi electron rule. And here see, this molecule is important one. Remember, this positive charge is present outside of the skeleton. So which means it is not involved in delocalization. In delocalization, only 6 pi electrons are regularly delocalizes like this. Only these 6 pi electrons are delocalizing. Okay. So this positive charge never affect on the delocalization of pi electron. Even if I write negative, even if I write radical, even if I write positive charge over here, that doesn't affect the delocalization of the 6 pi electrons. So now this molecule is said to be aromatic in nature. So now this skeleton is very, very important. This skeleton generally you can also represent like this. Here it is a 8-membered ring. 8-membered double bond, double bond, double bond, and here I can write -1 and here -1. That becomes -2. So if I write -2 in a 8-membered ring, which indicates that every corner carry one unhybrid p electron. Additionally 2 electrons. So 8 plus 2, 10. So I can write like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this skeleton having 10 pi electrons. If this skeleton, even if it is a positive charge, suppose if I write like this, a positive charge and here positive charge. Even if it is a positive charge, it is found to be aromatic in nature. Even if I write a -2, think like this. If I write +2, you think like this. Here 6 pi electron delocalizing, here 10 pi electrons are delocalizing. 10 pi electron delocalization follow 4n plus 2 Huckel's rule, and see, it is found to be aromatic in nature. So all are aromatic in nature. And finally, last question. Aromatic molecule among the following are. Out of these 4, which among the following is a aromatic, I am asking. Now remember, in imidazole, one proton is added on one of the nitrogen. But actually this lone pair, initially existing lone pair is not involving in delocalization. So you can imagine like this. Initially this molecule is aromatic. This is aromatic in nature, imidazole. Here one lone pair of electron is present. But this lone pair is involving in delocalization, but not this one. So if they are involving in delocalization, in nuclei, only 6 pi electrons are delocalizing. 1, 2, 3, 4, 5, 6, but not this lone pair. But whenever if you add any proton, if this base takes this proton, you will get a conjugate acid. In this conjugate acid, only this lone pair will take this proton and this lone pair will disappear. Even though this lone pair disappear, that doesn't affect this 6 pi electron delocalization. So still nuclei carry 6 pi electron delocalization, it is found to be aromatic. Okay, right? Next go through this one. Pyridine. Generally we know pyridine can be represented like this. Pyridine bearing positive charge is pyridinium. Initially pyridine carry lone pair of electron outside. After adding a proton, it becomes a pyridinium. So before adding proton, this lone pair is not involving in delocalization. Nuclei carry aromatic. 6 pi electrons, and this is aromatic. But after adding proton, still there is no lone pair, but nuclei carry 6 pi electron. It is still aromatic in nature. Okay, so when lone pair present outside of the skeleton, if it is not involving in delocalization, if it is not responsible for aromaticity in molecule, on that time you can ignore that lone pair. So here this lone pair is not involving in aromaticity. Even if this participate in reaction, that lone pair, even if it is disappear, molecule becomes aromatic. And if you consider, it is looks like an indole. If I write nitrogen, that is indole. This is a oxygen heterocyclic ring, benzo-bifuran. If I write only this one, furan. Furan is aromatic. If I write this one, this is aromatic. Even this is benzo-bifuran. Benzo-bifuran also aromatic in nature, because if I take these two non-bonding electrons, out of two lone pair, one lone pair involved in resonance. So 2 electron, 6 pi electron. Now total 2, 4, 6, 8, 10. Now total ring carry 10 pi electrons are present. So 10 pi electrons, this ring is found to be aromatic in nature. It is also aromatic in nature. It is also aromatic in nature. Now see, here one of the oxygen out of two lone pair of electrons, you need to contribute only 2. Only 2 lone pair electrons can participate, but not total 4 pi electrons cannot involve in resonance. Out of 2 lone pair, only 1 lone pair involve in resonance. Remaining lone pair is not involved in resonance. Simply remember, if I write a lone pair outside, it is not involved in resonance. If I write lone pair inside, that lone pair can involve in resonance. So in this case, only this lone pair can involve in resonance. 2, 4, positive charge, connectivity is there, continuous conjugation, 6, 8, 10. So now total ring carry 10 pi electron delocalization, and this molecule is said to be aromatic in nature. Okay, so these are few examples regarding concept of aromaticity. Just make a short revision on these questions. See, the number of aromatic compounds among the following. A group of molecules are given. Sometimes in your examination, they will ask a integer type of question. They will give group of molecules and they will ask, find the number of aromatic molecules involved in that one. They will ask a number, 5 molecule, 4 molecule, like that. This is one such type of question I explained. Next. If you focus on this molecule, some conjugations and some non-bonding electron delocalizations and external carbonyl are given. So how to check aromaticity for such kind of molecules? If any carbonyl is present, try to transfer pi electron to oxygen, then you will create a positive charge like this. This skeleton you need to check like this. So transfer this and you will write negative charge on oxygen, and here you will get positive, and only this set we need to consider for delocalization. Here also same, here positive, 6 pi electron, here also 6 pi electron, all are aromatic in nature. Now be careful with this molecule and this regularly repeated. This is a 10 aniline. 10 aniline is unstable, and this is a completely non-planar molecule due to transannular interaction. So this is non-planar and this is completely planar. It is also called oxypin. 8 pi electrons are delocalizing, and finally due to sp3, this is not a aromatic molecule, it belongs to non-aromatic. So finally I can say that A is a aromatic molecule. So 2 more questions will be there, just already explained. So these molecules are very easy, so you try to pay more attention on this molecule. Generally you people think that when positive charge is present on the ring, what to do, whether it is a delocalized or localized. Remember, this positive charge is localized. Only 6 pi electrons are delocalizing aromatic. Here -2 means already 3 double bonds are present, 2 extra charges are given. So remember, in your examination, if they given like this, you need to imagine molecule like this. Otherwise remember, every corner one unhybrid p orbital is there. You just count 1 electron for every corner. Total 8 corners, 8 electrons are present, 8 plus 2. -2 means 2 extra electron, 10 pi electron. Even if I write plus 2, that is also aromatic. Okay, so all are aromatic in nature. So remember, if any lone pair inside involve in resonance, if any lone pair outside not involve in resonance, 6 pi, 6 pi, 6 pi, 6 pi, all are aromatic in nature. Okay, so that is about aromaticity question series. Hope you people understand. So try to subscribe our channel so that new videos and new questions will be updated regularly, so that you can listen and you can apply for any kind of entrance, and that questions becomes very easy for you. Okay, thank you for watching. Thank you for subscribing our channel.